Hello and welcome. Today we're going to talk about Karnaugh maps with 6 variables. And I hope you watched my videos about the 4 variables and 5 variables before watching this one. As you see here, I have 4 tables arranged in a specific order. As you see here, from this table to this table, only one variable changes, v bar, here u bar, here v bar, and from here to here only one variable changes. This is very, very important. Now, if you take one of the tables, excuse me, you see that here yz bar, y bar, z bar, y bar, z only changed in only one variable. From here to here, change in one variable. The same thing here. wx bar, etc. See, that's very, very important. Now, I will not be giving you the expressions to minimize. I will give you its map. So, but we know what that means. If you look at this star here, this represents u bar, v, w, x bar, y bar, z bar. This one here, light brown, it represents uv, w bar x, y, z bar. And this one here is uv bar, w x bar, y, z bar. And this last one here is u bar, v bar, w bar x, y bar, z. Now I want you to identify the stars, and every time you see this icon, you pause the video so you can solve the problem and come back and check your answer. So you see here, this one here is u bar v, w bar x bar, y z bar. This one here is uv, w x bar, y z bar. And this one here is u v bar, w bar x bar, y bar, z bar. And this one here is u bar v bar, w x, y bar, z. And I hope you got it right. Now we're going to do some simplification, minimizations of expressions. Remember, you need to use the largest blocks, groups of 2, 4, 8, 16, 32, 64 adjacent terms, combinable terms. So let's think of that and solve it and come back. Okay, here we go. These 4 can be blocked together, and it's coming from only one of the tables. So you have u bar v, all of this cancel, y, z. Here you have 4, 4, 4. Like this, you can't really do any grouping because too many differences. See, u, v, and u bar, v bar. Here you can't do either, anything like that. Now you can have these 2, this one and this one. And then you have v bar cancels, you have u. Look at this here in only one of the tables, it doesn't matter. So you see here, w cancels w bar, you get x bar, and here you get z bar. Now for this one here, if you take these 4 alone, you get an equivalent expression, but it's not in its minimum form. So you have to group these 2 together. And you see here, u bar cancels, you have v bar for sure. And then here you have x bar, z bar. V bar, x bar, z bar. And I hope you got it right. This now. This one is the same as the one before, except I added these 2 stars here. So this will be the same as before. And these will be the same as before. And these will be the same as before. And now these 2 here, you group them with these 2. And now they're coming here, this green, only one table. So you have u v bar, here x bar, and here y bar. So u v bar, x bar, y bar. And that's the answer. This one is on you again. Okay, this is the same as before. The same as before. The same as before. And this is the same as before. So now I added this star and this and this. Now you can group this one, this one, this one, and this one. Since they're coming from 4 different tables, so u, v, u bar, v bar cancel. So look at it from here. You have w bar x, y, z. And that is the answer. Up next. Now, all of these can be combined actually together. This, all of these. And what you get, u, v, u bar, v bar cancel. Now just look at one of the tables here. These two here will give you x, and these two here will give you z. X, Z, the answer. Up next. This one here now, you see this 4 here, here, here are all can be grouped together. And that will give me u, v, u bar, v bar cancel, will give me here w bar, y. Now I have this 4 and these 4 can be combined. V cancels v bar, you get a u. Look at this here now, all of these cancel. W bar x. Now these two here, this one you can combine it with this, but that will add a term that you really don't need, because in order to reduce this, you have to take it with this. And that will give you u, v bar, w, x bar, z bar. Now this one here is left alone. It can't be combined with anything, so you have to leave it alone. U bar, v bar, w, x, y bar, z. And that is the answer. Next, this is your turn. It's easier than the one before. Now you see, you take this 8, 8, 8, 8, 32 terms together. U, v, u bar, v bar cancel. Here, all of these cancel. Here, x cancels x bar, you get w bar. Now, these 4 here, if you take them alone, you won't get, you get an equivalent expression, but not in its minimum form. So you have to combine these together, these 8 together, coming in only one of the tables. So u bar v, and here x bar, that's it, u bar v, x bar, because all of these cancel. And that is the answer. Now, your turn. Now, this one here is kind of a little bit more kind of difficult to see, but you can combine these. 32 terms, u, v, u bar, v bar cancel. Look at one of the tables now. All of this cancels. Obviously, here you have w cancels w bar, you get an x. Now you can take this together now. And again, u, v, u bar, v bar cancel. Here, all of these cancel. Look at this is y, z, y bar, z. So only z. So x plus z. And that is the answer. Up next. All right, here. If you look at this 4 here, you can combine them together, no doubt about it. Now, you can't really do anything between these here because there are too many changes. Look, Y, Z, and Y. Here you have U bar and Y, and Z here you have U and Y bar. So there's too many changes. So you can't really combine. You can't combine this way anyway. You can't combine. So with this one will be left alone, U bar V Y Z, and this is also will be left alone, U V Y bar Z, and this one will be left alone, U V bar Y Z, and this one here, U bar V bar Y bar Z. Now, if you look at any of these two terms here, these two here, there's too many changes. Look, U changed and Y changed. Look at these two here, U changed and V changed. Look at these two here, V changed and Y changed. So there's no more simplification. And that is the answer. It's your turn. Now here you see, look, you can take this 4, 4, 4, 4 terms together, U, V, U bar, V bar cancel. Then look at only one of the tables, all of these cancel, you get W bar X. Now, you can get this 8 and this 8 together. U cancels U bar, you get a V. Here, all of this cancel, you get Z bar. Okay, I'm left with, I notice that these two here, 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 I can take them. Here, I can take these. Together, U, V, U bar, V bar cancel. If I look at one of the tables only, I get here W, Y, Z bar. I'm left with this one here, so I can take these two together. Here, U cancels U bar, you get a V bar, W, X bar, Y. And that is the answer. It's on you now. Now, this one, obviously, you can take these 32 terms together. What happens is all Y, Z, Y bar, W, all these cancel. You are left with only V. Now, you can't take 6. Remember, 2, 4, 8, 16, 32. So I can take now this 4, this 4, and this 4. Excuse me. Then I get U, V, U bar, V bar cancel. Here, W cancels W bar. Here, Y cancels Y bar. So you get X bar from here and Z bar from here. And then you can also do this 4, 4, 4, 4. And you get WZ bar. And that is the answer. This one is easy. Here you have to take all of these together, 64 terms. And if you are working with Boolean algebra, you get a 1. If you are working with logical expressions, you get a T for true. And that's the end of Karnaugh Map 6 variables. Please write a comment if you like it, and subscribe. Thank you, and see you later.